Shear stress, an example of simple stress. And we have a problem. The suspender rod, is supported at its end by a fixed connected circular disc. If the rod passes through a 40 mm diameter hole, determine the minimum required diameter of the rod and the minimum thickness of the disc needed to support the 20 kN load. The allowable normal stress for the rod is 60 megapascal and the allowable shear stress for the disc is 35 megapascal. To get the diameter of the rod, we can just use the formula of area of circle. Since the rod is circular, we can use the area equals to pi r squared, or simply A equals to pi diameter over 4 squared. And now, since we have two unknowns, the area and the diameter, we can find the diameter yet. So, for this, we can use the formula of the stress, which is stress is equals to force over area. We can just manipulate the formula and we can get the area equals to force over stress. And now, we can use the area equals to 20 kilonewton, which is the force, the load pulling the disc and the rod, and the 60 megapascal, which is the allowable normal stress. Now, we can just use the 20 times 10 raised to 3 to turn the kilonewton to newton, and the 60 megapascal times 10 raised to 6 to turn the megapascal to newton per meter squared. And the answer will be 0.3333 times 10 raised to negative 3 meter squared. And now we have an area, we can just use our formula of area of circle. A equals to pi times diameter over 4 squared. And just use the 0.3333 times 10 raised to negative 3 meter squared as an area equals to pi times diameter over 4 squared. And now we have the diameter of 0.0206 meter or 20.6 millimeter. And now, for the thickness of the disc. Since we can see that this is also circular, we can just use the formula of 2 pi RT, which is the circumference of the disc and the thickness of the disc. And just manipulate the formula. We can have the thickness equals to area over 2 pi r. And again, we have two unknowns, which is the thickness and the area. And with that, we can use the formula of area equals to total force over tau, or the shear stress. And now we have, again, we can use the 20 kilonewton as the total force, which is pulling the load, and the 35 megapascal, which is the allowable shear stress. And it will be equate to 0.571 times 10 raised to negative 3 meter squared. And now, since we have an area, we can just use the thickness equals to area over 2 pi r. Now we have the 0.571 times 10 raised to negative 3 meters squared all over 2 pi times 0.02 meters. 0.02 meters comes from 40 millimeter diameter. And now we can use now we have the answer of 4.55 times 10 raised to negative 3 meters or 4.55 millimeters. And thank you. Okay na.
Pakiramdam eh. Ay.